ever since man first began to take interest in his natural surroundings, he has struggled to arrange and classify the objects around him. He has searched for patterns which might allow him to predict and shape what was to come next. A seaman watches the clouds and wind to gain warning of an approaching storm. A hunter studies his prey to know better how to trap it. Or a farmer rubs the soil in his hand to determine what crops will grow best.
Hello, I'm Therese Rath. Belize is a country of great natural diversity, from the dense forests of the Chiquibull to the offshore corals of the Barrier Reef. By studying the natural history of Belize, we can attempt to understand the patterns of nature which influence our lives. Has Belize always been as we see it today? Why are we blessed with the hemisphere's longest barrier reef? How do we influence nature? These are some of the questions we will attempt to answer. For in unraveling the patterns of the present, we may be able to choose the best path to the future.
Understanding the natural history of a region is a complex task. Climate, topography, and soils combine to form a variety of habitats, which in turn give birth to many different forms of life. Climate is determined by the location and topography of a landmass. Topography, or the lay of the land, is the result of movements of the Earth's surface modified by the forces of wind and water. And the soils are a function of geological history, erosion, and the movement of water. Where should we begin?
Before there was light, before there was air, before there was life, there was rock. Most of us feel that our feet rest firmly on stable, immovable ground, but scientists tell us differently. They say that the continents are in constant motion, fueled by the heat of the Earth's core.
Though the continents appear stable during our short lifetimes, earthquakes and volcanoes are a testament to the geological turmoil beneath our feet. North America, Honduras and Nicaragua, South America and Belize all lay on different continental blocks, floating seemingly at random towards and away from each other. As the continents drift and landmasses collide, mountains are thrust up out of the earth, while volcanoes spit molten rock. By identifying the results of these past continental upheavals, we can trace the paths Belize has traveled to the present. Our story of the natural history of Belize begins over 350 million years ago. At this time, all the world's landmasses were joined to form two colliding supercontinents. Current scientific theory says that the land which would become Belize was tucked into what is now the Gulf of Mexico. Honduras and Nicaragua lay to the north, and Africa lay close to the east coast of North America. Belize was poised to make a long journey to the present. Evidence of this journey lies hidden about the countryside like pieces of a giant puzzle. In the oldest exposed rocks in Central America, we find our first clues. 350 million years ago, shallow seas covered the region. Particles in the water settled to the bottom, forming what is known as sediments. The extreme pressures caused by the ever-shifting continents transformed these early sediments into sandstone and clay. These materials, subjected to heat from the Earth's core, were altered into the hard rocks known as metasediments. These exposed boulders of the mountain pine ridge at Baldy Beacon are the oldest rocks in Belize and the sole representatives of the geological foundation upon which Central America lies. The two supercontinents were never still, colliding together with overwhelming force. When the continental masses began to slide under one another, rock turned liquid, volcanoes erupted violently. This is what happened under what is now the southern half of Belize. The heat generated by the movement of continental crust melted the earth. The molten masses of rock began to rise, spewing lava and volcanic bombs thousands of feet into the air. As Belize continued to move, the flow of molten rock slowed, and the exposed lava cooled, then hardened into a mass of volcanic fragments over a half a mile thick. Few remnants of this ancient upheaval still exist. A 50-kilometer-long lava outcropping in the Bladen Nature Reserve, called Little Quartz Ridge, is the only known evidence of volcanic activity in Belize. Forces deep within the Earth soon caused the mighty supercontinents to rupture. Africa began to drift eastward, creating a young Atlantic Ocean. North and South America began to separate, and the continental plates upon which Belize and Honduras lay began to uncurl, giving birth to the Gulf of Mexico. The Belizean landscape did not escape these powerful forces. The splitting of the Belizean block from the Honduran block caused rock to buckle and fold. Sandstone and clays were again heated and compressed into hard metasediments, and the Maya Mountains began to rise for the first time. During this period of mountain building, one of the defining geological events in Belize's past occurred. The Earth's crust, deep beneath the surface, split at least 3 times under the young Maya Mountains. One fault opened under the Mountain Pine Ridge region. Another rose below the Mullins and Stand Creek Valley regions. And here in the Coxcomb Basin, a third massive plug of molten rock emerged to the surface, filling the entire area with the largest dome of granite Belize would ever see. Victoria Peak and the Coxcomb Range stand as a monument to this intense heat and pressure. As the period of mountain building and granite formation came to a close, Belize was already twisted 120 degrees, opening up the Gulf of Mexico and settling into its present-day location. But temperatures worldwide were rising, causing glaciers to melt and sea level to rise. Throughout the tropical regions of the Earth, the advancing shallow seas were drowning forests. Warm seas engulfed the Maya Mountains, and except for the highest peaks, most of Belize was underwater. On land, the dominant creatures, namely the dinosaurs, were also the largest. Underwater, however, the most important creatures were the smallest. Their long poetic names, Foraminifera, Coccolithophores, and Radiolarans, belie their tiny size. Most are microscopic. These small animals absorb minerals from seawater and transform them into portable houses we know as shells. As these creatures die, their shells rain down upon the shallow ocean floor, forming layer upon layer of ooze. As the centuries passed, billions upon billions of these skeletal remains accumulated into layers thousands of feet thick. Eventually, the pressure from the layers above compressed the layers below into the rock we call limestone. Massive deposits of limestone, some over 2,000 feet thick, once blanketed the entire country. Though Belize had settled into our present-day position almost 60 million years ago, comfortably nestled against the North American plate, the Honduran block continued to rotate and slide east. As the two blocks ground against each other, forces once again bent and folded the land, pushing the Maya Mountains into their most recent period of uplift. As the Maya Mountains rose, the forces of wind and water immediately began to carve them up. The blanket of limestone covering the loftiest heights was the first to erode. The young Raspaculo and McCall rivers created immense watersheds carrying tons of soil to the west and north, depositing their loads on the northern lowlands of Belize. The young Stand Creek River and the Swayze branch of the Monkey River also chipped away at limestone and eventually hit the huge granite dome then filling the Coxcomb Basin. Granite erodes faster than the surrounding quartzite, so that what we are left with today is a huge depression surrounded by massive peaks and ridges of quartzite and shales. The geological journey of the Belizean landscape is never-ending. The rivers continue to eat away at the Maya Mountains, filling in the coastal areas, creating soils, and extending the shoreline.
It is erosion which has sculpted the landforms we have today, converting rock into soils. The formation of soil is a complex process. Once rocks are exposed to wind and rain, they begin to weather, dissolving, splitting, and disintegrating into ever smaller fragments.
Wind and water then move these particles, which continue to grind and scrape against each other, mixing with other tiny fragments from different types of rock. The rivers and winds eventually deposit the particles layer after layer in valleys and deltas, creating soil. And it is soil which largely determines in Belize what plants will grow where. So to understand the pattern of vegetation in Belize, we need to understand the pattern of soils. As a result of complex natural processes, several hundred different types of soils have been created. Still, they are grouped into two general categories, either rich in lime or poor in lime, depending on the type of rock that various rivers ran through. Northern Belize consists mainly of limestone soils with islands of quartz sand. The south-central portion of the country is dominated by the granite and quartzite of the Maya Mountains. To the north and south of the mountains lie beds of limestone which are still being eroded away. Along the coast lie accumulated sediments washed down from the mountains. Finally, in the far south are beds of limestone again. Limestone is another name for calcium carbonate, the solidified remains of the tiniest of sea creatures. These massive blocks of stone are subjected throughout history to the same forces which forged the Maya Mountains. Fissures opened up in the limestone as the Maya Mountains grew, and these cracks allow rainwater to pour in and get through the rock.
The flowing water erodes the limestone, forming vast underground chambers with subterranean rivers. In a labyrinth of caves, nature sculpts strange formations as the water dissolves the calcium carbonate and then rebuilds it into stalactites and stalagmites. As these formations only grow about 1/16 of 1 inch each year, the larger ones may be thousands of years old.
Water is still seeping into the rock as cave formation continues today. The dissolving properties of water on limestone can also be seen above ground. Here on the Vaca Plateau, the McCall River has cut deep gorges into the surrounding limestone rock right down to the hard granite below. High above, the water continues to dissolve the limestone, making it flow like liquid while sculpting masterpiece waterfalls of stone. Water is the key to both the formation and the erosion of limestone. In fact, if the geology and soils are the structure upon which nature grows in Belize, water is the blood cycling the nutrients necessary for life. Every form of life known needs water to survive, and in most cases, the amount of water present determines what will survive and what will perish. The pattern of rainfall and climate in Belize will likewise determine, along with the soils, what vegetation and animals will survive. Generally in Belize, the further south we travel, the more rain we will experience. Corozal town in the north receives on the average 50 inches of rain a year. For 3 or 4 months out of the year, Corozal experiences a dry season where little or no rain falls. Punta Gorda, on the other hand, lies on the coastline near the Guatemalan border. PG will receive on the average 166 inches of rain a year, and the dry season there sometimes lasts only 3 or 4 weeks.
Living organisms do not exist in isolation. Fish cannot survive without clean water. The trees cannot survive without nutrients in the soil, and farmers cannot grow food without the seasonal rains. It is the surrounding physical environment which will define what will thrive and where. It is the parent rocks of a region which will determine what kinds of soils are produced. The soils and the climate will influence what types of vegetation will thrive, and the types of vegetation will control what animals will inhabit a region.
Belize is a land of contrast. A complex geological history has created numerous landforms and hundreds of different types of soil. Our climate provides wet and dry seasons, hurricanes and heat. When we begin to mix these environmental ingredients, the number of combinations is mind-boggling. This is reflected in Belize by the astonishing array of vegetation. Belize is estimated to have over 4,000 species of flowering plants. This includes 240 different orchids and over 700 species of trees. To put this in perspective, there are only 730 species in all of the United States and Canada. Belize's wealth certainly lies in the diversity of our natural resources. But does this great diversity of vegetation fall into patterns similar to landforms, soils, and climate? Forestry in Belize has a long history, from the logwood cutters of the 17th century to the timber industry of today. British Honduras made a name for itself with mahogany. Of all the natural resources, our vegetation is probably the best known. The forests of Belize are classified under 4 broad categories. 13% of the Belizean landscape is covered by open forests of pine and savanna. These include the large savannas of the northern plains. 19% of our forests are mangrove and swamp habitat. These areas are some of the most productive and important ecosystems in Belize. Cahoon palms cover an amazing 6% of Belize. The cahoon palm occurs throughout the country and is one of the most distinctive trees in the nation. Finally, by far the largest part of our forests, 62%, is classified as broadleaf forest. These are the true jungles of Belize, the closed green canopy which covers much of the Maya Mountains. Each of these forest types can be broken down into more specific categories. For example, scientists have described 50 variants of the broadleaf forest, 17 variants of the swamp and mangrove forests, and 10 variants of the pine and savanna habitats. One variation which grows on rich, well-drained soil is the cahoon forest. Looking around, it is easy to see the dominant plant, the cahoon palm. The floor of the forest is littered with fallen fronds and nuts.
This litter makes for very rich soils, and we would expect the soils to be very dark and nutrient-rich, which they are. Large fronds provide shade year-round and prevent the growth of many competitor plants. The shade also keeps the soil quite moist, and the lay of the land provides good drainage. It is not surprising then that the cahoon palm has very narrow tolerances for groundwater, not too wet, yet not too dry.
On the other end of the soil fertility scale is the stark but beautiful pine savanna, better known in Belize as pine ridge. The dominant plants are Caribbean pine, oak, and the palmetto palm. The soils of the pine ridge are sandy and stony. Most of the nutrients have been leached out. In the wet season, plants must deal with poor drainage and standing water. During the dry, conditions are parched and fire occasionally sweeps the landscape. This is a very harsh environment where only a relatively few hardy species can survive. Many of the plants here have evolved adaptations to cope with the seasonal wildfires. When pines, for example, have reached a certain size, Their bark becomes very thick and can withstand the fast-burning fires. Many of the grasses have underground parts which regenerate quickly after the fires have passed. Some scientists theorize that if fire was prevented from burning the savanna, broadleaf forests would return. Yet, the soils are exceedingly sterile, and without the addition of fertilizers, it is doubtful that anything but these hardy plants would grow here. It's amazing that any animal life can survive in the open savannas of Belize, but a number of organisms have found ways of scratching a living out of this habitat. The most common large animal is the white-tailed deer. They prefer the open areas where they can see great distances and browse on the young shoots of grass after a fire. One of the more spectacular creatures of the savanna is the magnificent jabiru stork. Though they feed in the marsh and swamplands, they nest high in dead pine trees in the open woodland. Life is a continual struggle in nature, the struggle to reproduce and to eat. Nowhere on land is that struggle more apparent than in the rainforest. Broadleaf forests cover over half our country, not counting the areas of transition between other forest types. 29 variations of broadleaf forests have been identified. These are the rainforests of Belize. The rainforest is one of the most complex ecosystems on Earth. A newcomer to the forest is usually overwhelmed by the absence of any patterns in the vegetation. A deep, impenetrable green pervades everything. There are strange noises, deep shadows, and still air. In fact, our tropical rainforests are so complex and diverse that a precise definition is impossible to give.
But if we take the time to look and study, some order emerges from the apparent chaos. We can begin to discern layers. The first thing we notice is that most plants are trees, and that the trees grow to form a dense canopy over us.
Below this canopy is a relatively open zone filled with vines and branches, but few leaves. Large winding climbers seem to tie the forest together. Lower down still is another layer of tall shrubs and young trees. Taking a closer look at the larger trees, we see that many of the trunks are buttressed at the base. Other trees look as though they are perched on stilts. Still others have large leaves and spiny stems. Finally, the forest floor is littered with leaves, dead branches, and fungi. Each one of these layers is a habitat in itself, with intense competition for resources. The struggle begins at the very highest layers of the canopy. Sunlight is the primary source of energy for the rainforest. Plants use sunlight to bind water from the roots and carbon dioxide in the air into sugar in a process called photosynthesis. Photosynthesis takes place in the green leaves of a plant. About 80% of the food for the entire forest is produced in the canopy. The canopy of the forest is closed as the trees spread out their leaves in an effort to maximize the amount of sunlight they gather. It is impossible to see the ground from above. We also notice that the canopy is uneven. There are differences in crown shape, density, and even color. It is obvious that the forest is a mix of many different species of tree, that no one species dominates over another. Besides the canopy trees, vines called lianas and air plants called epiphytes are the major plant life forms in the rainforest. Lianas are very conspicuous, found snaking along the ground or climbing tree trunks toward the canopy. They come in many sizes and shapes. Like the rainforest trees, lianas are in competition for sunlight. The only way they can reach the upper canopy is to find a tall tree to grow up. One of the more spectacular lianas in Belize is known as the basket tetai and is actually a species of palm. This climbing palm is armed with slender needles like spines and is one of the longest vines in the world, reaching lengths over 1,000 feet.
Many of these lianas form travel routes for the animals through the forest. They also tie the forest together so that if a single tree falls, other trees tied together by the lianas may fall as well. These vines and lianas can eventually choke off the sunlight to the host tree, essentially starving the tree to death.
An extreme example of this is the strangler fig tree called matapalo. Strangler figs often start off life as a small plant high in the branches of a host tree. With time, the strangler sends down roots that wrap around the tree. Eventually, the roots reach the ground and develop in the soil, while hanging roots grow and expand, completely surrounding the tree and crushing it by constriction. Epiphytes are another conspicuous group of plants in the rainforest. Some of the more spectacular epiphytes belong to the orchid family. The orchids have evolved some of the most beautiful flowers in nature. Epiphytes are plants that grow on trees without contact with the soil. This causes a few problems for the plant. How does it access water and minerals for growth? Epiphyte leaves are thick and succulent and used as storage for water, much as a cactus does in the desert. Many epiphytes arrange their leaves to catch rainwater. Looking inside, you are liable to find a whole ecosystem of animals within the pool inside the plant. The sun fuels the growth of plants in the forest, the vegetation using the solar energy to produce sugars. These sugars are a valuable food source for a variety of organisms. Insects in all their phenomenal diversity abound in the upper canopy. Scientists have estimated that 50% of all organisms alive are insects living in the canopy of the rainforest. Most of the insects are practically invisible, never seeing the ground or interacting with man. It is easy to overlook their importance. Nevertheless, insects indirectly provide unexpected benefits to human life. They are pollinators, assisting a multitude of plants with reproduction. Birds of broadleaf forest feed on insects, fruit, and other animal life, and are one of the more visible animal groups in the forests of Belize. There have been over 530 species of birds recorded countrywide. Over 300 of those use the broadleaf forest to either feed, breed, or escape from the northern winter. The scarlet macaw is Belize's largest and most magnificent parrot. But this spectacular forest bird is in danger of extinction due to the loss of habitat. The agami heron is a very rare bird throughout its range, including Belize. This beautiful forest bird probably nests in the more remote areas of broadleaf forests, along streams or swamps. Most of the birds in the forest are those that eat insects. The common parakeet is all but invisible on the forest floor, but will dart up and catch insects at will during the evening and night hours. What we are seeing is a series of changes, a passing of energy from one form to another, a chain reaction, so to speak. In fact, scientists call this the food chain. Vegetation, which produces the initial input of food, is the primary producer. The insects, birds, and animals which consume the vegetation are called primary consumers. The next link in the chain are the secondary consumers. What about the top consumer? The top consumers of the forest include the most magnificent creatures in all of Belize, the wildcats. The jaguar is probably the most well known. This beautiful cat lives in the lowlands of our broadleaf forests and savannas throughout the country. It feeds on birds, like the parakeet, but more usually on large mammals like peccary, armadillos, and even fish. The top consumers in a food chain are good indicators of how healthy an environment is. You might ask, what happens to the jaguar? How does he contribute to the system? The top consumers control the animal population they feed on. By preying on the sick, diseased, or weak, they ensure that the animal population stays healthy. Imagine what would happen to the rat population in Belize if we removed hawks, snakes, and cats. Their number would multiply, spreading disease and sickness among humans. But the top consumers contribute to natural systems in another, passive way. This is the beauty of the cyclical systems in nature, and where the forest floor becomes so important. If the canopy is the power plant for the rainforest, then the forest floor is the recycling plant. The rain in rainforest usually refers to the amount of precipitation which falls from the sky, but it could also refer to the constant rain of leaves and branches and dead organisms, including a jaguar when it dies. All this material is quickly broken down into minerals and recycled through the forest. Very little material is incorporated in the soil. Competition for nutrients and runoff from heavy rains does not allow much nourishment to accumulate in the soil. Early ecologists and land use planners used to think that rainforest indicated fertile soil. This notion is almost never correct. The forest depends for nutrients almost entirely on recycling. At any one moment, the majority of nutrients is stored in the biomass, the roots, stems, leaves, flowers, and fruits, and also in the animals of the forest. All these components will eventually die and fall to the forest floor. Decomposition will take place thanks to the many fungi and insects which inhabit the litter. Decaying organic debris is the major source of plant nutrients in the forest.
We have only just begun to explore the complexity and intricacies of the rainforest, but we have identified structures such as the layers of vegetation, patterns such as the food chain, and cycles such as the flow of nutrients. But where do we, as Belizeans, fit into the natural processes of our environment?
Some Belizeans live directly off nature. The chicleros, for example, harvest from nature without destroying, as does the collection and use of medicinal plants. In other words, some sectors of our society selectively remove resources without drastically changing their environment, while others completely alter the landscape. All living organisms change the environment to some extent, but these changes by living things encourage recycling and rebirth. Man generally disrupts the opportunities for renewal. Agriculture, such as the citrus, banana, and sugarcane industries, as well as in some ways the Maya-Milpa system, continually struggle against the regrowth of natural vegetation. Belizeans have now progressed, if we can call it progress, to a level where we can create whole new ecosystems and substitute them for natural ones. A large dam across the McCall River could supply electricity for our entire country. Yet, it would alter the natural drainage and flow of the river. We would be creating an artificial mountain lake where once there was only forest.
In the greatest alterations to our natural environment, Belizeans have embarked on a path of urbanization. We are replacing most of the natural elements in our environment with artificial ones.
Instead of soil full of microorganisms and recycling fungi, we are covering the city with concrete or tar surfaces, making transportation easier. Instead of the natural vegetation, vegetation which builds and protects our coastlines, providing habitat for a greater diversity of life, we have flattened and buried the low-lying mangrove to build housing for our ever-growing population. And instead of the natural plant and animal communities of the wild, we have suppressed nearly all life that once existed there, substituting a community of little variety, mainly dogs, cats, and unfortunately, creatures which thrive off man's concentrated refuse: rats, houseflies, cockroaches, and lice.
There is no denying that in general, the man-made community works efficiently, at least for the time being. A natural community, as we have seen, is a fabric of food chains interconnected into a web of stability. We are beginning to simplify and rearrange these webs of stability to suit us. We are shortening natural food chains and eliminating any competitors which conflict with our interests.
Because insects consume our food crops, we spread insecticides that eliminate not only these competitor pests, but many beneficial forms of life as well. The object of agriculture is to grow pure stands of crops, single species of plants that we can directly eat. But the single crop system is always in a precarious position. It is created by man and has to be maintained by man through chemicals and machinery. It is man working against nature, an artificial system with all the dangers and uncertainty of the unknown. Epidemics become an ever-present threat. A general principle of ecology is that the more complex and diverse a biological system is, the more stable it is. Just as the health of Belize's economy is promoted by diversified investments, so the health of our environment is promoted by a diversified ecology.
Economics usually governs our relationship with nature. Economics, at first thought, requires us to concentrate selfishly and arrogantly on our own immediate needs, to regard nature as a resource for exploitation. But further thought shows the error of this idea. The danger of environmental selfishness is like the danger of selfishness anywhere. The momentary gain eventually ends up in loss and defeat.
Very historic cultural site.
Fortunately, Belize is just beginning the task of development. Much of our natural systems and diversity of life are still intact. And we are benefiting from the same technology which in the past fueled the destruction of natural systems. Our land and natural resources are being inventoried. Development is being planned, often with environmental concerns in mind. Now in Belize, development is often planned, not with a total alteration or transformation of the resource into something else, but with the idea of sustaining the resource, leaving enough so that the resource will regenerate and continue to give today, tomorrow, and to our children. The concept is called sustainable development. In the northwestern part of Belize lies an innovative program called Program for Belize, which is attempting to put into practice the ideals for sustainable development. Through the mixed use of small-scale agriculture, forest management, chicle extraction, wildlife study, and archaeological research, Program for Belize hopes to link development and conservation in ways that advance the objectives of both. Joy Grant is the Managing Director of Program for Belize.
Here at the Rio Bravo Conservation and Management Area, we have the infrastructure in place to attract scientists to look at many different areas. But I think it's important to say that with research, you have to first establish what you have by looking at the flora and fauna of the area, and then you use that as a base to look at sustainable development. I think it's very important that scientists feel comfortable that they will be able to work at a certain area on their project for maybe 10 or 20 years. Here at the Rio Bravo, we hold this land in perpetuity for the people of Belize, and that is a very important point to scientists. Also, we provide trainees to work along with the scientists, and these people are usually from this area, and they come with a wide knowledge of the area, which is very important when you are doing research. The question as to whether Belize can develop and also maintain and protect the important habitats is, of course, the question that we grapple with every day. I feel confident that we can, because we have organizations that are strong and I think very committed to protecting the environment, and they're doing a very good job to accomplish this. I also feel strongly that the work that we are doing, looking at the projects and looking at ways for sustainable development, is the way that we should be going as a nation, and that the answers that we will have to the questions as to how do you do it, what do you need to make this work, that we'll be able to share this with everybody in the country, and then come up with a successful balance between development and the preservation of the environment.
But sustainable development cannot cure all our environmental ills. While sustainable development strives to find ways to allow nature and man to coexist to the mutual benefit of both, it is protected areas which provide regions where nature can exist and thrive without impact from development. Administered by the Belize Audubon Society in a unique partnership with government, the nation maintains a large system of protected areas which encompass a diversity of habitats. Among them are the Coxcomb Basin Wildlife Sanctuary, which protects almost 150,000 acres of broadleaf forest and one of the highest densities of jaguar in the world. The Bladen Nature Reserve encompasses a large and diverse area of forest, ancient Maya sites and limestone caves in southern Belize. Half Moon Cay Natural Monument supports one of Belize's largest colonies of nesting water birds. Five Blues Lake National Park, just off the Hummingbird Highway, was opened in 1994 and is already being visited by an increasing number of tourists. Belize has come a long way from those first sediments of 350 million years ago. Only within the last 1,000 or so years, a mere 50 generations, has man begun to compete against nature in molding our landscape. In many places around the world, the separation of man from his environment is complete. Many countries are paying the price through starvation, pollution, and overpopulation. Today, Belize is precariously perched between the ruin of unplanned development and the responsibility of coexisting with the environment.
Our journey has just begun. Our generation is leading the way now, but we shall soon pass on the leadership, responsibility, and environment, or what's left of it, to our children. Of all the principles of ecology, the primary one was stated over 300 years ago by Francis Bacon. We cannot command nature, he said, except by obeying her. It is a principle we should all ponder.